Okay, 60. Sketching curves is an important skill to master. An understanding of limits is also required when sketching the more challenging curves. So, e to the x is a very steep curve. It increases extremely quickly, which means when you multiply it by something else, it is the dominant curve because it is usually much larger than everything else, right? So, in this expression here, I thought I had noise, it's a bit weird. Um, there is something, no? Hearing things. The limit as x is approaching infinity of x times e to the negative x. Now, I've just told you that the exponential part is dominant, okay? So out of these two things that are being multiplied together, the e to the negative x is dominant, okay? If I'm going to infinity, what is e to the negative x approaching? E to the negative x is up here, and it's going that way, it's getting below. It's getting close to 0. So even though x, David, x is going up to infinity, this one is approaching 0. And because it's dominant, it's going to make the whole thing go to 0. Okay? There is a noise. What is that noise? Oh, okay. It's outside. The next one, this is kind of the same thing. As a general rule, even for e to the x is dominant over x to the k. So same deal here. If I'm going to x is approaching infinity, the e to the negative x, which is going to 0, is dominant over that x to the power of whatever k is. K could be a big power, but the exponential is still dominant. And so that whole limit will be approaching 0. Okay. Question number 1. Sketch the graph of y equals x times e to the negative x after carrying out these steps. First of all, what is the domain? Okay, domain is talking about x values. Is there any restrictions on the x value for the exponential part? No, because you can have any x value, you've got the curves going that. And x itself, like y equals x, that's a straight line. It can also be any value of x, right? So what do you think the domain is? Oh, you guys are geniuses. All real x. B, test whether the function is odd or even or neither. So how do I do that? Yes. So let's call it f of x because it was y before. So if I say f of x is equal to x e to the negative x, I want to sub in f of minus x, which would be negative x e to the positive x. Now, if that comes out and it's the exact same thing as the original, that would mean that it is even. But it's not. So then we try to bring out a minus sign. So I go minus, and that would be x e to the x. Then, if what's in the bracket is the same as the original, then it would be odd. Is that the same as that? No. So, it's neither. I said neither. Yeah, correct my job. Question C. Find any zeros of the function and examine its sign. So the zeros are when y equals 0, right? We're talking about the intercepts on the x-axis. So let's sub in when y equals 0 into the original equation that's up in the very beginning there. So that's 0 equals x e to the negative x. How do I solve that to find x? That's in the way. Otherwise, that would be an interesting idea. Other options. It's null factor. You have two things times together to give 0. So that means that either the x equals 0 or the e to the negative x equals 0. Okay, so this one obviously is a very nice solution. How do I solve this? Then you might think about doing a sliding base, but does e to the x, think of the graph, e to the negative x, can that ever equal 0? No, there's an asymptote there. So, thank you. So there is no solution. Are you making fun of me? Ah, okay. Okay, so there's only one 0 and it's this one. But there's more bits to this question. Find any zeros and examine its sign. A sign table means you have x values up at the top. Then we want to see what's happening to the y values because we want to see what's happening to the sign around our 0. So 0 goes in the middle. I need a number less and a number bigger. So -1 and 1. Hopefully are the obvious choices. Sub those in to, you're subbing them into here, into the y, right? So it's -1 times e to the positive 1, because the minus and minus, makes negative e to a positive 1, or just negative e. Subbing in 0, you get 0. That was the whole goal, because 0 times by whatever that is still 0. Then, subbing in 1, you get e to the negative 1. Now, this minus sign tells me that's about minus 2.7, right? This is a negative. It's negative on that side. 0, e to the negative 1. Is that a positive or a negative number? It's very small, but it's positive. Okay. Part D. Examine the function's behavior as x is approaching infinity and negative infinity, noting any asymptotes. You may assume that as x is approaching infinity, that x e to the x is approaching 0. So we did this in our graphing topic. As x is approaching infinity, that would mean that y would be pretty much equal to, in my equation, it's x e to the x. I'm just putting infinities in there. So it's infinity e to the negative infinity. Now, because we're going to infinity, it's saying what does it approach? 0. And again, you could think of that as because this is dominant. Remember we talked about the exponential being dominant? It's not. Okay, so this would be approaching 0. So even though that's infinity, infinity times 0 is just 0. So that means that y, go away, y is approaching 0. Okay, now let's do the other one. As x is approaching negative infinity. So that would be y is negative infinity e to the positive, because 2 minus make a plus. This time, this is still the dominant here. The e to the infinity is dominant. Stop smoking when I say that. It's math related. Okay, then e to the infinity is approaching what? Infinity. Okay, this one's not going to 0. That's infinite right there. Infinity times infinity is still infinity, but there's a minus sign there. So y is approaching, what do you think? Negative infinity. All right, we've still got a few more bits to find before we can draw this thing. Question E. I know it's all just one question. Find any stationary points and determine their nature. Stationary points are when y dash equals 0. So remember, y equals x e to the negative x. What do I have here? I've got to differentiate it. It's a product. Okay? So u is going to be equal to x. V is equal to e to the negative x. U dash is 1. V dash is negative e to the negative x. All right, VUV times. So y dash equals v times u dash is e to the negative x plus v times u dash, well, let's just change it to a minus because of that minus sign, x e to the minus x. Or factorize the e to the minus x out, and it would be 1 minus x inside the bracket. That's just differentiating it. That took enough work already. I still haven't found the stationary points. So I'm now going to say that that derivative is equal to 0. The factorized version is very helpful here because now I can use null factor. Either the e to the negative x equals 0, which is no solution, or the 1 minus x equals 0, which means that x is equal to 1. That's the one I'm after. It is a point, so let's find a y value. Sub 1 back into the original, so it'd be 1 e to the negative 1, or just e to the negative 1. Okay, still not finished. Find any stationary points and examine their nature. Second derivative or a table of values? Ooh, second derivative. Do you know what fun you're in for? That's a product, people. Change your minds. Uh, I actually did do it with the second derivative, but let's do a table. Okay, so we're going to have x, y dash, and the slope. So we're checking 1, and let's check 0 and 2, because we decided that that might be easier. So this should be 0 and flat. So now sub 0, and you'll need to tell me if that down. 0 into my first derivative. So that will be maybe 0 is a bad idea. E to the power of 0 is 1. Oh, it's 1. Okay, sub in 2. It's negative, but negative what? All right, 3, 8, or 3, 9 will do. Okay, so it's positive, 0, negative, which means that we've shown that it's a maximum at 1 e to the negative 1. Part F. Find any points of inflection and examine the concavity. Oh, we need the second derivative anyway. No, man. I knew there was a reason I did the second derivative. Okay, here we go. Second derivative. Shh, guys, please. Shh. U will be equal to e to the negative x, and v is equal to 1 minus x. Okay, so u dash is negative e to the negative x. V dash is negative 1. All right, let's put it into our product rule. So y double dash equals second derivative. VU dash is going to be the negative e to the negative x times the 1 minus x. Then plus, there's a minus sign there, so minus e to the negative x. If I expand that out, does something nice happen? E minus e to the minus x, and then plus x e to the negative x minus e to the negative x. I just have two of them that I can collect up. I was hoping they'd cancel out, but they didn't. So it's x e to the negative x minus 2 e to the negative x. They're the ones that collect up. And there is my second derivative. Okay. Now, the reason I needed the second derivative was for the concavity. How do I find points of inflection? When y double dash is equal to 0. Okay, so let's factorize my second derivative. It would be e to the negative x equals x minus 2. That's equal to 0. Because then I can null factor, and e to the negative x equals 0, which yet again, no solution from there. Or x is equal to 2, which is obviously the one that I need. Okay, so if x is equal to 2, it's a point. I still need a y value. Sub it back into, where is that original equation? Way back here, into there. So it'll be 2e to the negative 2. Okay, then, so I think I have a point of inflection at 2, 2e to the negative 2. Can I leave it like that? No, because I have to always make sure that it's a point of inflection by doing something else, which is a special table, the concavity table. Yes, excitement. Okay, the concavity table. So we have x's, we're checking the concavity, so second derivative, and we've got 2 is our number. I'm going to go all the way down to 0 because it's fun to sub in, and 3. You can do 1 if you like. So 2 should be 0 because that's the point of inflection, it's a point. If you sub in 0 into the second derivative into here, that's 0. So it's minus 2 times 1, because e to the power of 0 is 1. So that's just going to be equal to minus 2. If you sub in 3, oh, that's not quite as nice. If you sub in 3, you're probably going to get a decimal. All right, that'll do. 0.049 something you said. Okay, cool. All right, so the point is, if it's negative, it means it's concave down. Then the positive one means concave up. So the concavity has changed, and it is a point of inflection. So therefore, point of inflection at 2, 2e to the negative 2. Okay, finally, we're meant to draw it. Oh, we better draw it at the bottom here then. I need more room. What's the whole point to draw it? It says, question 1, sketch the graph using these steps. Yeah, so we've done all the steps, we should draw it now. Yeah. Yeah. All right, the drawing should look like this. Found a bit of space on my page, hopefully you have too. Now, we had let's go through the things we found. We found a point of inflection at 2. So 2 is there. And 2e to the negative 2. Now that's a very small but positive number. So that's just slightly above the 2. Let's put it there. Okay, so that was my point of inflection. Then I also had a stationary point at 1 over e. Now 1 over e is slightly bigger than 2 over e squared. You can get them as decimals. Both of them are less than 1 because they're 1 over. So if 1 was there, so let's put the other one here. It's going to be 1 and it was e to the negative 1. E to the negative 1. Okay, what else did we find? We found a 0 in part C. We found that it was going through the origin, the 0. So that means it's going through here. It's not odd or even, it does have all real x. Okay, in part D, we found out that as we're going to infinity, we should be coming out here on my x-axis, we're approaching what? 0. So this maximum is coming down, it's inflecting here, and then it's going to approach the x-axis, but never hit it. Okay? Then when we went the other way, when x was approaching negative infinity, where's my graph going? Negative infinity. So as I'm going to the left, this is just going to be really big negatives. It's going to just come way down here. So it comes up, down, and like that. There's that graph. That wasn't too bad. All right, question 2. Use a suitable transformation of the graph sketched, see like we did that in example number 1, to sketch y equals negative x e to the x. The one that we just sketched was x e to the negative x, right? So we just had y equals x e to the negative x. What substitution would I do to get to there? I would be replacing x with negative x. And when you do that, you get the y equals negative x e to the positive x. Okay, so replacing an x with a negative x does what? It reflects it over the y-axis. So what happens is my graph has been reflected in the y-axis. So now we can draw that. Look back at our other one. Can I see both of them? Oh, it's too far up the top. Okay, my turning point. So it's going to be over here on the negative side now, because my turning point was at 2, 2e to the negative 2. So it's going to be over here at negative 2, 2e to the 2. So that can be there. Negative 2, 2e to the negative 2. Then I had a turning, that was my point of inflection, sorry. Then I had a turning point, which was it was at +1, so now it's just going to be at -1. So it'll be -1 e to the negative 1. Then we knew this was coming down and getting really close to the axis. It's going to reflect it over, right? It goes through the origin and then gets really steep coming down there. We reflected it. How nice. And we're done. 6C.